Hi everyone, it's me. So in today's video, I actually wants to do chemistry as I promised you in my first video. I mentioned in my description that I say I will teach at maths, physics, chemistry, and mathematics, right? And when I do the video, I found out I did a lot of videos for additional mathematics. So I think now I have to do for chemistry and for the other subjects. So I think will be my first video for chemistry, but I didn't follow the topical order. I just randomly pick a topic, and the topic I picked for today is acid, base, and salt in Form 4 chapter. And guys, you know what? This chapter is very, very important. It's the basics of your chemistry. Begins from this chapter. So it's very, very important for you guys to understand this chapter. This chapter is the basics of chemistry. Begins here. So it's very important. Make sure all the SPM students must master this topic. And 2025 SPM has a very strong chance this chapter will be in an essay questions or a long structure question. So it's very important for you guys to master this topic. This topic is a must to master. And not only that, this chapter is one of the biggest or challenging chapter among the chemistry syllabus. It took a very long time, but honestly guys, this chapter is not very challenging, but this is what many seniors of SPM candidate students says. But trust me, this chapter is not challenging. If you understand the fundamentals of chemistry and how it applies in our real world, if you're able to imagine the chemical reactions, then this chapter shouldn't be an issue for you guys. It's just like a piece of cake. Understanding in this chapter is very important. Memorizing is after the understanding. Memorize is not a very important part in chemistry. Understand first. Things that you need to memorize in chemistry is always the definition. When I do my SPM, I would like to take a few minutes to share my tips also. When during my SPM time for chemistry, how I study was actually didn't memorize, frankly. I understand literally every chapter. I understand how it works. I do practice past year trial questions and understand how it happens, a chemical reaction, how it works. For example, acid. When it react with maybe a metal, what will happen? I didn't memorize, but I understand how it works. The process behind of the every chemical reaction. That's what I did. I didn't even memorize a single thing. I think for chemistry SPM exam, I started memorizing like 1 week before the exam, SPM exam starts. I memorized the definition, I memorized the procedure. I think these two things only. The procedure of experiments in chemistry, you have a lot of experiments, right? I memorized a few experiments, but actually no need to memorize everything. Go through because you know how it works, right? So you don't have to memorize also. You just need to remember a few keywords, like memorizing the definition and the procedure. The rest don't have to memorize. Understand and write what you understand. That's the important part in chemistry. So acid base and salt. I didn't go in topical order. Yeah, I just randomly pick a chapter because I feel like this chapter is like very, very important. So I do this chapter first. And of course, this is the longest chapter in chemistry syllabus. As you know, I can't just finish the longest chapter in just one video. It requires like minimum of 3 or 4 videos. I think 3 or 4 also is not enough. Maybe it's more than that. But anyway, I will try to finish this chapter as fast as possible. So for today, I'm going to cover the first part in this chapter is acid. I'm going to talk about acid today. Acid and base. But today's part is not too difficult or it's not related to understand it. Just go through only. For today's part, mainly they will ask in paper 1 objective questions. Paper 2, very rare they ask this part of questions. They don't ask so much. In paper 2, they mostly ask chemical reaction type of questions. So for today, acid and base I'm going to cover. So let's talk about acid first. So first thing, if you want to talk about acid, what is acid? It's very important for you to know the definition of acid, right? So let's go with the definition, guys. So the definition of an acid. So when exam asks you what is the definition of acid, it goes like this. Acid is a chemical substance. Acid is a chemical substance that ionizes in water. I'm reading too fast that I'm writing. Ionizes in water to produce hydrogen ion. This is the definition. Come to H plus. So this is definition, but the keywords is chemical substance must include in the definition. Ionizes water hydrogen ions. These are the keywords the examiner will look first. If they ask definition, this is the keywords that you need to mention. You don't have to memorize the entire sentence, only memorize the keyword. Chemical substance ionizes water hydrogen ions. So which mean example, let's go for example of acid. So tell me example of acid. In SPM syllabus there are 6. Actually, not 6. Quite more than that, but the main is this 6. But the very important is the 3 acid. In SPM syllabus, I think it's better to write the 3 example because mostly we're going to talk about that only. So in SPM syllabus, the important 3 acids are hydrochloric acid, we call it HCl. The name is hydrochloric acid. And nitric acid, the name is nitric acid. Next is sulfuric acid, which is H2SO4, and the name goes like this, sulfuric acid. And what the definition tell means, when you have an acid, you ionize in a water. When you put the acid, the HCl, put in a water, what happen is, so I'm going to write here, it will start to ionize. Even the word definition here says ionizes. So it ionizes in water, right? And when it ionizes, it will become like this. HCl will produce what? Hydrogen ions, right? They say produce hydrogen ions when it ionizes. Wait, why I couldn't make a circle? There you go. So that's what happens here. It will split into H plus. It will produce the hydrogen ion, and the Cl also will split, becomes Cl minus. Same for the others also. Nitric acid, HNO3. When you put inside the water, it ionizes, it produces hydrogen ion. So it split, become H plus, NO3 minus. And sulfuric acid, you produce hydrogen ion, and you have sulfate SO4, split them, but this one charge is 2 minus. You hope you know what the sulfate means, SO4 2 minus. And guys, don't forget, this is 2 hydrogen. That means when you split also it become 2 hydrogen ions. So you need to add a 2 there because there is 2 hydrogen ions there. So this is the definition basically telling. I just just explain them through a equation, ionizing equation. So next thing you need to know in this part is the basicity of acid. What is a basicity of acid? So basicity means refers to the number of hydrogen ions that can be produced by an acid. So basicity, I just write here. Basicity means is actually the definition means the number of hydrogen ions that produce. Who produced that? The acid, right? Produced by an acid. But just don't say acid, you need to add a keyword here, molecule. So if they ask what is the definition of basicity of acid, you say number of hydrogen ions produced by an acid molecule. This is the keyword that you need to mention. So it means number, how many hydrogen ions produced by the acid. For example, hydrochloric acid. We take the HCl. So when it ionizes in water, as you know, it's split to H plus Cl minus. You realize here is just one hydrogen. So that means it produced one hydrogen ion. That means that is the basicity of acid. And for one hydrogen ions, we have a name. If you produce two hydrogen ion, we also have a name. If you produce three hydrogen ion, we also have a name. So in SPM level, the maximum hydrogen ion that they produce is 3. So what are the basicity? Here. One is the monoprotic acid. Monoprotic, the word mono stands for one, isn't it? Mono means one. That means they're telling that it produces one hydrogen ion. Just one hydrogen ion per acid molecule. For example, HCl, hydrochloric acid lah. Example, I write here hydrochloric acid, HCl, nitric acid. Next, you also have another acid called ethanoic acid. Maybe this thing I didn't introduce to you. Now I use this time to introduce ethanoic acid, CH3COOH. The name is ethanoic acid. All these produce one hydrogen ion. As you can see, they just have one hydrogen. That's why they produce one. H here only got one. The H only one there. So it only produces one hydrogen ion. Next, basicity means diprotic acid. The next basicity here is diprotic acid. Di means two, isn't it? The prefix that we learn, di, mono means one, di means two, right? So exactly the same thing. Just change two. Produce two hydrogen ion per acid molecules. Example, sulfuric acid, which is this one, the third one. Can you see they produce two hydrogen ion? Sorry. You see, when they ionize, they give you two hydrogen because you have two hydrogen there. So when you put inside water, they ionize, they split, also will become two hydrogen ion. That's why it's under diprotic acid, the basicity of it. Next, carbonic acid. Also, I didn't introduce, I use this time To introduce you, what is that? The name of it is carbonic acid. Carbonic acid. Because here got 2H. You can see, oh no, my bad. Can you see here got 2 hydrogen and here got 2 hydrogen. So when they ionize, they also produce 2 hydrogen ions. That's why they are under diprotic acid. The up one mono, they only have 1H. But you can ask me, here got 3H, why this one not considered? Okay, that one is just under the carbon uh, chain, so it's not considered. Yeah, the H at the back only will take part in the reaction of acid. This H not take part is under a carbon chain branch there only. It will not take part in the reaction. The hydrogen that will take part in the chemical reaction of an acid is this, the behind one. Why like that? Actually, you will learn about this more on Form 5 Chapter 2, Carbon Compound. So you will learn more details on that chapter. Okay. So in Form 4, if you're Form 4 student, if you are watching this video, until this chapter you learn, you only need to know that the one for ethanoic acid, the hydrogen that will take part in the chemical reaction of acid is the behind one acid, the behind Scully. That is the acid they will take part in the reaction. Why? You will learn in Form 5 chapter 2, carbon compound. So don't worry, you will learn about all this. So next, we will take a look on triprotic acid, which is the third basicity. We call it triprotic acid. Sorry, I forgot the R. Triprotic acid. Tri means stands for 3, isn't it? That means they produce 3 hydrogen ions per acid molecule. They produce 3 hydrogen ions per acid molecule. Example, I will give you phosphoric acid. Example, just give you one, phosphoric acid. The name goes like this, phosphoric acid. Why? Because you see here got 3 hydrogen, right? So they ionize in water, they also produce 3 hydrogen. That's why it's under triprotic acid. Okay, so far? So this is the introduction of acid. So nothing much you need to know for acid. You need to know the definition and the examples of acid and how they ionize. The next, you need to know the basicity of acid, which is this one. And done. You're done with the acid parts. Nothing more to do with that. Now let's talk about the base. So what is base? I think I don't want to talk about the base for now. Let me finish everything more on acid first. Hope you guys are okay with that. Okay, I want to finish everything about acid first, like the role of water for the acid properties, to show the properties. I will finish that one and then I'll go to the base. Is that okay? Okay, let's finish about the acid first, then we go for the base. So for now, you already know the definition of acid. You already know the examples of acid. The main person in the acid is the hydrogen ion. The main person is hydrogen ion. You will realize in every acid here got hydrogen. because the main person who will take part in the acidic reaction is all hydrogen there. Next, you have basicity of acid, which means how many hydrogen they produce when they ionize in water. That's the idea, okay? How many hydrogen. So in SPM level, you just have until 3 level in basicity: monoprotic, diprotic, and triprotic. Mono means one, mono, single. Di means twice, like it's two or double. Tri means triple, which is 3. So they follow the prefix. So this one is not too difficult, right? Okay, now we're going to take a look of acid, how the acid behave when you put in water and not in water. So now we're going to talk about the acid behaviors. We already finished the introduction. We already talked about what is acid and the categories of acid, like the basicity. Okay, the basicity, like almost the category, how many type of acid you have. Now let's talk about how the acid will behave when they put in water. So the role of water in showing the properties of acid. Let's take a look on this properties of acid. So the important person here is water. The water will show the behavior of acid. So I have a two situation. Let's just say I will draw a box easier. Now let's just say I have a ethanoic acid. We choose the example ethanoic acid. For example, I choose ethanoic acid. The CH3COOH. So ethanoic acid. Here also I put ethanoic acid. We choose both also ethanoic acid. And now I have a beaker. Okay, let's just say I have a beaker. And in the first one is just dry, so there's nothing, just I put ethanoic acid. I just pour ethanoic acid. So when I pour ethanoic acid, CH3COOH, actually there's nothing will happen because it's just acid only there. There's nothing there else, only the acid. So you won't see any different. You only will see the CH3COOH, which is the ethanoic acid. Only this, which they will exist in the form of molecule. This is how they will look. But as soon when you add a water, so I write here ethanoic acid with water. So when you add a water inside and you put ethanoic acid, the ethanoic acid they will actually, what happen here is the H they will break. The water will break. The H, they'll split. When they split, this is how they will look like. The CH3 COO minus and H plus. They will become the oppositely charged when you add water. This is how you will see. H plus and then CH3COO H plus. Can you see the difference? When you add the water already, they'll start to split. So this is the difference. And what is the difference here? When there is no water, so this statement is very important. So in the absence of water, the acid exists as molecules because there's nothing. It's just acid there, so they exist as a molecule. No change at all. Exists as molecule. Because of their in molecule, you will not be able to see the hydrogen ions. So the hydrogen ions is not present. Ions are not present. So there's no hydrogen ions, correct or not? You will see they exist in the molecule form. It's just like one set, nothing there. So what happens if there is no hydrogen ion? There will be no acid. It's not considered acid. Because you know why it's not considered acid? Let's look at the definition, guys. Acid. What is acid? Acid is a chemical substance ionized in water, produce hydrogen ions. You see, ionized in water, produce hydrogen ions. But in this case, did you see any hydrogen ions? We already clearly highlight hydrogen ions not present. That means this is not acid, right? Because they are not acid, it cannot show the acidic property, right? So you can say acidic property is not shown. Maybe I should erase this, like very annoying. And if you look at here, when you add water, you can see the acid dissolve in water. So when they dissolve, it ionize, right? The acid molecules ionize. The keyword are very important. In this chapter, they like to see the keyword, very important. Ionize in water. When they ionize in water, they produce what? The very important chemical is hydrogen ion. So produce hydrogen ion. So water to produce hydrogen ion. And now you can see there is a presence of hydrogen ion. So there is presence of hydrogen ion, because as you can see, when you put in water, they split. The water is the agent that will split. Presence of hydrogen ion. So when you have a hydrogen ion, it's considered acid, right? So when it is acid, it can show the acidic properties. It can show the acidic behaviors. So you can say acidic properties is shown. So next thing, you need to know the ionizing equation. How can I forget this? So the ionizing equation is also important. Ionization equation. So let's just take example hydrochloric. Actually, we already do this, but just again a recap. Nitric, CH3, COOH, H2, SO4. So when they ionize in water, the water will break them into two. When they break, they will produce one product for sure, hydrogen ion. So no matter whatever, when they put in water, they ionize, right? When they ionize, they will produce hydrogen ion. That's what they clearly say in definition already. So no matter what, everything I got hydrogen ion. This thing for sure. This is the person, the hydrogen ion is the main person who show the acidic properties. Very, very important person. If there is no hydrogen ion, it's not considered acid. And then the remaining is the side product that you will see, which is the partner that you split with. So H and Cl, so you will see Cl, but don't forget the charge. Okay, but when you do, if you're doing chapter 6, you should be able to know the charge. The charge of ions is very important already. If you still cannot memorize the charge of ions, make sure you memorize them. So nitric will become nitric ion, and CH3COO minus, and here SO4 2 minus. But this thing is quite special. As I told you, H2SO4 is a diprotic acid. That means there is two hydrogen ion, right? That means they'll produce 2H plus. Okay, this is ionizing equation, which means they're ionized in water, and what you will see, the product. Oh, one more thing. This one, it's CH3COOH is a bit special. It's a weak acid. They are weak acid. So because of that, they ionize partially only. So you will not get full product. You don't see H plus CH3COO minus. You will see some, and the remaining some of them will combine, just get back together. So they will reverse back, and they will get back to H3COOH. Some will ionize, some they don't. So it's half. You will learn the weak and strong acid in later on. I think I'll do that on my next video. So until now, you just need to know the ethanoic acid is just a weak acid. Okay, so far, hope you're okay. And yeah, one more thing. This thing I forgot already. My bad. When there is nothing inside, it's like there's no water at all. We have a chemical term to call it. We call it glacial. Glacial means dry, which means no water. When there's no water, it will exist as molecule. Hydrogen ions not present, acidic properties is not shown. Exam also they like to use the word glacial. But when you add water, you will see acid dissolve, right? And the ionize in water, produce hydrogen ion. So there's a hydrogen ion. This will allow them to show the acidic properties. Okay, now let's I give you a example question. Let's just say I have a 2 test tube. This is a study of a simple experiment that they do to show whether there is acidic properties or not. So the experiment is quite simple. It's not too difficult also. I have 2 test tubes for example. One, this one, wait. Let me add maybe what should I put? Maybe nitric. There's a nitric acid, and I put a litmus paper. Oh my god, it turns to a triangle. A litmus paper. And I dip inside the acid. So this is a litmus paper. And there'll be a borderline. Same thing over here. Copy. Before that, I should erase this thing. Paste. But one thing different here, this nitric is just not a nitric, it's add water already. So it's like a nitric solution. Solution means got water. You should be able to know. So this one I call it experiment 1. This one experiment 2. So you have exactly the same thing, just one different. This one nitric acid, there's nothing, there's no water there, it's like a solid. But this one, this solid, you add water. What is the difference? What is the observation you will see in both experiment, and as well the explanation also? Observation plus the explanation. Short form, EXP means explanation. OBS, observation. So what you will see when there's a solid, if you put a litmus paper, can you see a hydrogen ion or not? The answer is no, because solid means there is no water. If there is no water, there is no presence of hydrogen ion, correct or not? They exist as a molecule. So because of that, they won't show the acidic properties. So the litmus paper will still be the same. So this one, I put a blue litmus paper. This one also same, blue litmus paper. So you will see the blue litmus paper remains the same. That will be your observation. Blue litmus paper remains the same. It will not turn into red. Why? The explanation. First thing, the solid nitric acid exists as molecule. Exists as acid molecule. Sounds more better. Acid molecules. So because of that, no presence of hydrogen ion. So because of there's no hydrogen ion, acidic properties is not shown. But here you add water, so the acid will ionize in the water. It will produce what? Hydrogen ion. It already says clearly in the definition, right? Which we learned. So there's a hydrogen ion, so you will able to see a change. So the blue litmus paper will change to red color. So that will be your definition. So blue litmus paper turns red. Why? Because the nitric solution ionize in water. Ionize in water. Why? It produces hydrogen ion. So because of there's a presence of hydrogen ion, acidic properties is shown. These are the keyword, and this is how you would explain in exam also. The keywords that you have to mention: the presence, the ionize in water, produce hydrogen ion, acid properties. These are the common exam questions for acid, this part of chapter, this part, the beginning one. But the favorite for this chapter is the salt, which I will cover at the very last part on the video on this chapter. I think that will be the last video, because this chapter is quite long. Done. So this is an example I give you. So one, in water, what you will see the change, and the changes can make a change in the acidic properties, right? For example, the litmus paper turns into red, and many more. As long as you see a change, there's a hydrogen ion, there will be a bit changes in the chemical reaction. I think this is the part you need to know for your acid. Now we can go for base. Yeah, acid nothing much. It's like quite straightforward. Base also same, quite straightforward. Let's talk about base. I think acid, this one should be okay already. And by the way guys, these keywords you also can memorize. It's actually you will use these kind of words in exam also. So yeah, you can use this. So you actually can copy down while listening to the video. The keywords, the points, it will be helpful. Hopefully. So now let's talk about base. But you know what? Base is not the important person here. The important person in this is the alkali. But in order to know the alkali, first thing you should know the base. What is a base? Base is a substance that neutralizes acid. Neutralize acid, and when you neutralize acid, what you will get will form a salt and water. You'll study more detail about this later on in the same chapter to form salt and water. This is definition. So base, there's example of base. Example of base, you need to know whatever metal oxide. The easy way I write is MO. M stands for metal, O stands for oxide. And metal hydroxide. This one I will write MOH. M stands for metal, OH is hydroxide. So anything metal oxide, metal hydroxide, MO and MOH is base. So MO I write here, MOH I write here. Example of MO, magnesium oxide. Metal, as long metal, magnesium oxide is a base. Copper oxide, copper is a metal, right? Base. Lead oxide, PbO. Potassium oxide, K2O. Sodium oxide. As long you see a metal and the oxygen behind the oxide, metal oxide is a base. And metal hydroxide like maybe magnesium hydroxide, OH2. Copper hydroxide, CuOH2. Copper is a metal. Iron hydroxide, sodium hydroxide. So all these are base. But what is alkali? Alkali come from the base. It's like alkali is the son and the base is the mother. So if there's no base, you won't get alkali. But what is the difference? Usually the mother and the son almost have the same characteristics, same thing. Almost they have the same attitude, the same face. Everything is almost the same. There's a bit different. There's like one or two different, right? Exactly. Same for this. Base is like a mother and alkali is like a son. The difference is just quite simple. So you need to know. Base, you have two type of base. First thing. One is a soluble base. Soluble in water. That means you put the thing in water, it's soluble. That is also base lah. And another one more, it's insoluble in water. Okay. Soluble in water and insoluble in water. So there's two types of base. But what is alkali? A base that is soluble in water is called the alkali. The insoluble in water, whatever base that is not soluble in water, it's not considered alkali. So if they ask me what is alkali, you have to know not all bases are soluble in water. As I mentioned here, there's soluble and insoluble bases. But the soluble bases only called the alkali. Soluble bases are called alkali. And mostly the soluble bases come from group 1 from the periodic table. For example, sodium hydroxide. Sodium is a group 1. Copper hydroxide is a group 1. Lithium hydroxide is all group 1. Mostly group 1 all is soluble and they are called alkali. But there are other group from the other group like group 2 also considered alkali. Like example, calcium hydroxide, barium hydroxide, all this also called alkali. Now let's take a look on definition. The important is definition. They like to ask definition. So what is the definition of alkali? The definition is it's almost the same like the acid. There's no difference. There's like 1 or 2% only you change the name. The rest is the same. So how alkali is a chemical substance that ionizes in water to produce just 1% name only different. In this case, it's not hydrogen ion but hydroxide ion. To produce hydroxide ion, OH minus. As you can see here, like the main and a lot, like literally every alkali have OH, 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 OH. So they are the main person, the representative of the alkali is the hydroxide. OH minus. For acid is H plus, right? For alkali is OH. And of course, we also have a ionization equation and examples of alkali. So yeah, we will talk about examples of alkali. Although I already listed here, just to be a formal, I've read it again, and you also might remember again, more better. So example of alkali, which is the same thing like sodium hydroxide, potassium hydroxide, calcium hydroxide, lithium hydroxide, and yeah, we also have ionizing equation like, okay, so here I write the ionizing equation also. Ionization equation, this is a short form. So for example, the ionization equation, I will just pick some of it. Sodium hydroxide, and how the ionization equation look like, it's also quite similar like the acid, and maybe calcium hydroxide. So as you see, they will produce a chemical substance ionized in water. When they put in water, you will automatically see a hydroxide ion. So no matter what, you will see OH minus. Everything got OH minus. OH minus. And then the remaining is the sodium, Na, but don't just put Na, put plus. The charge is important. K, K plus. Ca, Ca, but Ca not just Ca plus, 2 plus. And also here got 2 OH minus, so 2 hydroxide ion. And one more thing, calcium hydroxide is a weak alkali. So because of that, they also will ionize partially. They will half will split, half will come back fixed together. So the equation will look like something like this. It's like a weak alkali. But mostly it's considered strong. In your SPM syllabus, you will not learn this in a weak alkali. You only learn one weak alkali only, which is the ammonia. But I will not cover that in today's video. Maybe on my next video I will do that. Yeah, in your SPM syllabus, your weak alkali is not this. It's just ammonia. But when you do further studies in chemistry, and you will realize that calcium hydroxide is also a weak alkali. And yeah, also I think it's important for you to know the applications of alkali. Where do you use alkali? Like in our daily life, we use alkali in most of the places. For example, when you wake up in early morning, you go to the bathroom, first thing you brush your teeth, and the toothpaste is an alkali. So example of alkali in our daily life, like a toothpaste. You know the Colgate? It's an alkali. Next, a soap. You take a shower, you put a soap, and then yeah, that's an alkali also. And what else? Like a lot. Some bleaching cleaner also consider alkali. It depends. Applications. I write here applications easier. And did I do for acid the applications of acid, like examples that acid you see in our daily life? There are a lot also. Alkali also you will use for one more thing. In agriculture, you know sometime the soil will get acidic. When the soil get acidic, you put alkali. So when you put alkali, it will neutralize. It will turn into salt and water, because that is the function of an alkali. Because you see, base is basically alkali, so it's a substance, it will neutralize the acid. So alkaline is the person who kills the acid in the form of water and salt. So if anything acidic, you will use alkali. So you know sometimes the agriculture, the tana, the soil will get acidic. So you know what the scientists will do? They will put alkali. When they put alkali, it will neutralize, it will kill the acid. It will cancel off the acid, the H plus, and then it become a neutral. So it will not be acidic. Even in the water pollution, if sometimes water got acid already because of acidic rain, and it connect in the water, so the beach or any ocean, it become acidic already, they will put alkali. It will neutralize, the alkali will neutralize the acid. So one of the application also in agriculture. And most common alkali they will use in agriculture is calcium hydroxide, calcium oxide. Mostly calcium. Calcium is the one most commonly they use in agriculture, because calcium is good for plants. They will use calcium mostly. And anyway, how I didn't do for acid, my bad. So I think I use this one to use for acid also. Acid, what is example? Drinks like Coca-Cola, gastric juice, drinks, any carbonic drinks, all these got carbonic acid. So in food industries, you will use that. especially for carbonic drinks, got carbonic acid. This is application. Application in our daily life, food industries. What else? Battery, car battery, yes. You know the car battery, the electrolyte inside is actually acid. Yes, the car battery. Inside the car battery got sulfuric acid. The electrolyte in the battery is sulfuric acid. Oh yeah, one more thing. Medicine. Yeah, alkali. You know a tablet for medicine. If anybody got a gastric, right? Gastric means got acid in your body, in your stomach especially. You have too much hydrochloric acid in your stomach if gastric. So if you go to the clinic or anywhere hospital or pharmacy, they will give you an antacid. Antacid means anti-acid, which means alkali. They will give you alkali. If you go to the clinic, they will give you a medicine called antacid medicine. It's for the gastric pain especially because it will antacid is actually is what magnesium hydroxide. Yes, it's magnesium hydroxide. Magnesium hydroxide is alkali, so it will go into your stomach because your stomach got acid, right? Gastric acid, right? So the hydroxide will cancel out the hydrogen. They will form water. They will neutralize. If you go to clinic, or I think they also sell in 7-Eleven also. No, 7-Eleven they don't sell. But in 7-Eleven there's one biscuit called, I forgot the biscuit name. It's also can also cure the gastric pain because that biscuit actually got alkali inside. Also got magnesium hydroxide. But I forgot the biscuit name. We call it magnesia biscuit. Magnesia biscuit. If you go to 7-Eleven, they also got sell this magnesia biscuit. If you got a gastric, you got too much of pain of acid, you buy magnesia biscuit and you eat it, it will neutralize the pain. It will cure the pain. So yeah, we are done with applications for acid and alkali. Now, same thing. We are going to study the behavior of alkali when you put inside water. We are going to talk about the behavior of alkali now. And you don't have to worry for alkali, we don't have a basicity of alkali like monoprotic, diprotic, triprotic. We don't have to worry about that. We don't have in your SPM syllabus. So don't have to worry. We just need to next cover straight away for the behavior of alkali when you put inside water. So role of water. In showing the properties of alkali. So I'm going to do almost the same thing like how I did for the acid, which I have two beaker. Oh my god. Actually, I'm going to split them. And yeah, copy, paste. I'm just too lazy to draw that again. Okay, here you go. Alright. So let's just use one alkali, maybe a sodium hydroxide. So in the first beaker here, I put just sodium hydroxide. There's nothing, just sodium hydroxide. So when it's just sodium hydroxide, you will only see like this. like they're in a solid, because there's no water, they cannot move. You actually almost, to be more specific, you won't see like this also. Sodium hydroxide actually like this. They consist of two ions, right? Na plus, OH minus. So to be more specific, I draw. You will have Na plus, OH minus, Na plus, OH minus. They cannot move freely. Something like this. They are stuck. When you don't have anything, you just put sodium hydroxide only. So something they are stuck, they cannot move. You realize the ions are actually, they are stuck. Because of that, they cannot move, because there's nothing there. So because there's no water, in the absence of water, because they just contain the sodium hydroxide only, the OH minus ion and the Na plus ion cannot move freely. So because of they cannot move freely, the OH minus ion is not moving freely, right? So it's considered not present there. If it can move freely, only it can show the properties of alkaline. So alkaline properties is not shown. Now, what happens if you add a water? So here I put sodium hydroxide. Here, the sodium hydroxide, if I add water, what will happen? The changes that you will see. The moment when you add water H2O, the Na plus and the OH minus, right, they will split. They will split. The Na plus will come one side. And the OH minus will go one side. And the OH minus may be over here. The water will split them. And now actually you will realize they have more space. So because of that, they can move freely. So in this case, but I forgot to do the box. My bad, I forgot to do the box. Okay, let's continue this. Sorry guys, sorry for my bad. Okay, anyway, let's get back to this. So I forgot to do the box here. I'm going to do this. Yeah. And you realize the OH got a lot of space. They can move around the OH. Can you see? There's like a lot of gap here. After you add water, you can see the space there. So because of the OH has space and they can move freely, they actually can show a change in alkali properties. So the NaOH ion, this is how you should explain if they ask in exam. NaOH ionized in water to produce freely moving OH minus ion. The word freely moving is very important, because just now also they have OH minus ion. Here also they have OH minus ion. So when you just put it produce OH minus ion, you will not get any marks. But when you say a freely moving, then only you will get marks, because the difference that will differentiate between these two is the freely moving. The OH minus here got stuck. They cannot move anywhere. But the OH minus here, you have a lot of space that it can move there. So you need to mention the word freely moving. So you need to understand what happens actually over there. So freely moving OH minus ion. And because of the presence of OH minus ions, you actually can see the alkaline properties. So alkaline properties is shown. I'm again going to do a simple experiment test and how they do in chemical lab. It's just a very simple test, guys. They take a test tube, and the same thing for here. And in this, I use sodium hydroxide since it's my favorite. This sodium hydroxide here is in a solid, maybe. Oh wait, I don't use solid. We call it another name is pellet. Yeah. Yeah, it's better to write here also pellet. Just now glacier, acid we use glacier, alkali we use pellet. Pellet means no water, dry. So if I write pellet there, you should understand there's no water. It's just dry. And I put a litmus paper, but this time a red litmus paper. Over here is a sodium hydroxide solution. And yeah, I did the same. Over here, I put a litmus paper. I dip a litmus paper, a red litmus paper also. And I named this as experiment 1. And I call this as experiment 2. Let me complete. So yeah, now I'm gonna extend this line. Give me a moment, guys. Let me finish this. And here also the same thing. I just wanna do observation and the explanation. Why you say that? Because exam love to ask the observation and explanation. So if you put in a pellet which is there's no water there, you will not be able to see the OH minus ion. You won't see the freely moving OH minus ion. So if there's no OH minus ion, what happened to the litmus paper? There will be no change, isn't it? So that will be the answer. The red litmus paper remains the same. Red litmus paper. I write short form here. LP means litmus paper. Remains the same. That will be my observation. And why did I say that so? Because there is no presence of water, because of there's no presence of water, OH minus ion is not present. Or you can say cannot move freely. Also acceptable. So alkaline properties is not shown. Because the representative of alkali is OH minus hydroxide ion. But when you add a water, NaOH solution means got water there. So you will see a change in the litmus paper, right? A red litmus paper will turn blue. So the red litmus paper here will turn blue. And why? Because there's a presence of water, and because of that it produces a freely moving hydrogen. So in the presence of water, you can say NaOH solution ionize in water to produce freely moving hydrogen. And now you have a presence of hydrogen. This presence of hydrogen allow to show the alkaline properties. This is how you explain it. And yeah, we are done. Oh, but I also want to do the ionization equation with you guys. So ionization equation here will be, I just do that, but this one, this is the ionization equation, but I will do again just for you guys to understand it and more better. Ionization equation, because as I see for in paper 2 chemistry SPM, they really love to ask chemical equation, ionization equation, thermochemical equation. You learn it from 5 statutory thermochemistry. So now you don't learn, but they like to ask a lot of chemical equation. Literally every structure question they'll have like 1 or 2 chemical equation, and overall chemical equation like this will be 8 or 10 chemical equation. So that worth like 16 to 20 marks. So you should be able to answer that without any mistakes. So ionization equation is the same thing. Potassium hydroxide. Let's do ionization equation for potassium hydroxide and sodium hydroxide. Yeah, do it again so that you remember it more better. And this time the ammonia, I told you just now, right? Ammonia. We also will do ionization equation for this. Okay, for potassium hydroxide, when you put inside water, you will see OH minus for sure. And not only that, the potassium ion, they split. They'll split. You'll see potassium ion all one side, OH minus all one side. And same for the sodium hydroxide. I also showed from the drawing, right? So here will be Na plus and here will be OH minus. But NH3, I told you it's a weak alkali. I will explain this more better in my next video. It's a weak alkali. Because of their weak alkali, they cannot split by itself. You need to add a water. And when you add a water, and one thing for sure you will see is actually OH minus. Definitely you'll see OH minus. But not just only that. You see H plus, H2O consists of two things. Right? One is H plus, one is OH minus. They both combine give you H2O. And this OH goes here. So this H plus will be with NH3. So this NH3 will actually react with H plus. And this will give you NH4. That is what you will get here. NH4 plus. It's a dative bond. You learn in chapter 5, right? Chemical bond. This is called a dative bond. ammonium ion. We call the name of NH4 plus is ammonium ion because of weak alkali. And not only that, because if it's a weak alkali, the equation also will not be full. It will be half will split, half will they come back together like NH3. They will exist as molecule. Some only they will ionize, some they don't. So that's why the equation also be like half equation like this. And yeah, I think we are done for ionization equation also. And yeah, I think I already covered for acid and base, the alkali. But of course, not the strong alkali, weak alkali. I didn't teach about the pH. I didn't teach about the properties. I didn't teach about the chemical equation, how you form a chemical equation. I didn't teach about that. I will teach all that in my next videos. Okay, don't worry. This is the introduction of acid and base, as well as the alkali. So this is all you need to know for the introduction. So yeah, and if you like my way of teaching, don't forget to like, share, and subscribe. See you. That's all for today. Bye.